In this problem, you're to find the greatest common factor of given terms. So let's say if you're given the terms 12x squared y, 30x to the 6th, y to the 3rd, 42x, y to the 9th. Now when you're finding the greatest common factor of these terms, you first find the greatest common factor of their coefficients. So in this case we have 12, 30, and 42. So we're asked what is the largest number that divides into either one. Now in case you can't see that right away, what you can do is to break down each number to their prime factorization. So we have 12, 30, and 42. So let's see, we could think of 12 as 4 times 3, which can be broken down even more to 2 times 2 and then times that 3. So that would be the prime factorization of 12. You could also think of it as 2 squared times 3. 30 we could think of as 6 times 5, which would also be, the 6 can be broken down to 2 times 3 times 5. And then the 42, that would be 6 times 7, which would be 2 times 3 times 7. So this is the prime factorization of those three numbers. Now the GCF has the factors that are common to all three of them and raised to the lowest power that occurs in any one of them. So in this case, for the GCF of these three values, well, let's see, they all have a 2, they all have a 3, but they don't all have the 5 or the 7, so that's not in our GCF. Now the lowest power of the 2 that occurs in any one of them is to the first, because in the second and third numbers it only shows up once, so it'll only show up once in the GCF. And the same thing for the 3, it shows up only once in each one of them. So the GCF of the numerical coefficients would be 2 times 3, which would be 6. Now for the variables, it's the same, except the variables are already broken down to their prime factorization. So we would just have to think, okay, so the GCF for the whole terms would be, we saw that 6, and let's see, they each have an x, they each have a y. Let's see, the x, this shows up twice in the first one, 6 times in the second one, but only once in the third, so it's only once in the GCF. And let's see, it's only once in the once in the first one, 3 times in the second one, 9 times in the third one. So it's only once in the GCF. So our GCF in this case would be 6xy. Now looking at another example, you have to find the GCF of these three terms, where we have 16 a to the 4th, b to the 9th, 12 a to the 3rd, b to the 10th, and 28 a to the 5th, b to the 9th. So we do the same thing. We first find the GCF of the coefficients, and once again, let's just say, if you couldn't see, what was the largest number that divides into all three of the coefficients? You could break down those numbers to their prime factorization. So we have 6, 12, and 28. So 6 we could think of as 4 times 4, which each one of those breaks down to 2 times 2, and then we'd add times 2 times 2, so that'd be 2 to the 4th. The 12, that'll be 4 times 3, which would be 2 times 2, and then that times 3, so 2 squared times 3. The 28, that would be 4 times 7, which would be 2 times 2 times 7, so that'll be 2 squared times 7. So for the GCF of these coefficients, well, let's see, the only prime number that they have all in common would be the 2, and the smallest power that occurs for the 2, well, let's see, we have 2 to the 4th, 2 to the 2nd, 2 to the 2nd, so the smallest power that occurs in any one of them is 2 to the 2nd. So our GCF, the coefficient will be 2 to the 2nd, which is 4. And let's see, they all have an a, they all have a b, so we'd have the a's and b's. Let's see, this is for the smallest power of the a's, we have a to the 4th, a to the 3rd, a to the 5th. So the smallest powers of the a would be the a to the 3rd. And for the b's, we have b to the 9th, b to the 10th, b to the 9th. So the smallest power of the b's would be to the 9th. Now we got to take the smallest power of those because it's got to go into each one of them. So if we took a larger power, like let's say b to the 10th, then that wouldn't go into the first and the third term. So that would be the GCF for this example.